All right, so welcome everyone to Java Object-Oriented Programming Workshop. So this workshop is kind of like is aimed at kind of beginners / intermediate people. So if you don't have any background programming in Java, that's fine as well. We'll cover everything from the basics. But if you are looking for some more advanced kind of Java topic, we also cover that as well. Obviously we can't cover everything in like an hour. So we'll see how far we can get to. And otherwise, I'll also post the slides after the workshop so we can refer back to the slides for those that we haven't covered. Okay, so first slide, start setting up. So ideally, you would want to have a chance to actually code along with me. So if you are trying to familiarize yourself with the syntax and style of Java, that would be a good idea to do it. But otherwise, you can just listen to me and watch me code if that's what you prefer as well. So before we start, does anyone have any questions? All right, so Java. So some very basic things about Java. Java is a compiled language. What that means is that when you write Java code, right, you write the Java code in English, right, almost English anyway, and then it's compiled to bytecode by the compiler. So you have a compiler, and then so you have to kind of compile all the English words into a bytecode. And then the bytecode is then interpreted or compiled by the JVM, Java Virtual Machines, to run. So in some way, Java can also be interpreted as a interpreted language like Python. But so Java is also a mix, but it's more, I would refer to it as a compiled language. But at the same time, it's also interpreted after it's compiled. So it's kind of get a bit confusing. So every Java file has to have at least one class. And there's only methods in class in Java. And if you're familiar with Python, you may be familiar with functions, stuff like that. Methods, so there's no kind of like functions in Java because every Java file is a class, and functions in a class is called methods. So we only have methods technically in Java. And when you're trying to run a Java program, so what the JVM will do is that it will look for the main methods, and that's the entry point to a program. So if you don't have the main methods, for example, in a Java file, you can actually run the class or the file. And well, sometimes it's not necessary to have the main method. So for example, if you don't want, for example, the class or the file to be run, then there's no point of having that main method. And it's very common in web applications to not have the main method because it's basically calling from other classes and stuff like that. Yeah, but if you're not executing a program, there must be at least one main method somewhere in your program. Just a quick demo. So here's one very simple, actually very simple Java program. What it does is that it will print out hello world in the console. So this is the main method. So what you have to do is that you have to run this. So this whole thing is compiled into bytecode, and then it will be interpreted by JVM, and then it will print out something in the console. And so if you just kind of like delete this kind of main method, there's no way for this to run. So if I can just do a quick demo, you can just change this to a random method, for example. You can't actually run this. There's no way for me to run this and stuff like that. So you have to kind of like keep it in main so that you have a way to actually run the program. Okay. So a lot of those, if you're familiar with programming, a lot of those kind of like basic commands, like, all those operators, Boolean comparisons, they're also quite transferable to Java. So some quick demo. So if you want to print something, you have to use system.out.print hello world, and system.out or system.out.print line. This print ln just means print lines. What the difference between the two is that print does not add a new line after you print the thing, but print line add a new line to it. So if you can just run it quickly, you can see that the first print doesn't add a new line, or the second print adds a new line. So anything else that prints after this actually goes into the new line. And equality, so this checks for equality. So 2 is obviously not equal to 3. So this will print out false, as you expected. And also comes some operators. 2 plus 3 give out 5. So this is just some simple operators. And this is just an operation. This is the device operation. So it gets the remainder. Sorry, yeah. Not remainders. Yeah, the remainders of this operation. So 2 divided by 3, you get a remainder of 2. That's why it prints out 2. And this exclamation mark followed by an equal sign, just check for inequality. And this gives out true because 2 is not equal to 3. And then this is just less than symbol. And this thing is and. So it's a conditional comparison. So if you're often with Python, you can just use the keywords and. But in Java, you have to use this double and sign. And then with or as well, it's like this double kind of like thing, double kind of straight line thing, instead of just the keyword or. So this is something that's kind of like new to Java. And if you have learned Python before, this would be something quite different. So 2 and 3 and 3 and 2. So this is true, but this is false. So this will just print out false. 2 or 3, this is true. 3 less than 2 is false. But since this is or, and one of them is true, it just prints out true. So whenever you have or comparisons, if at least one of the statement is true, it will print out true. And if you want to compare the type, for example, so hi here is an instance of string. So this is string. And I want to check whether it is an instance of string. And it is. So this is true. Now, a lot of this, so I'm writing this on IntelliJ, right? And a lot of this actually give like errors and warning signs because all these comparisons are not sort of like necessary in the sense that you don't have to compare it, right? Because this is, by looking at it, this is always false. So there's actually no point comparing it. So whenever you're trying to compare something, I guess one advice I give is that compare something that's less certain in the sense. So trying to compare things when you're running a program, trying to compare things that immediately that is going to be either true or false. So does anyone have any questions? So just a quick kind of like warning and stuff like that. These are not the only operators that Java has. There are a lot more. Feel free to search it out online or stuff like that because obviously I can't cover everything, but just kind of like some kind of quick demos that I have prepared. So before we move on, does anyone have any questions? Okay. So some code conventions of Java. So when you want to write classes, the first letter and also each internal word must be capitalized. So for example, you want to write a class name called basic commands, the B and C must be capitalized. And for methods and variables, they use camel case. So the first letter of the word is normally not capitalized, but then each internal word is capitalized. So for example, run fast is a method, for example, and this F is capitalized, but this R does not start with a capital letter. The same thing with variables. So if you have a variables called my letter, L needs to be capitalized. Okay, these are just conventions. Even if you don't follow the conventions, the code will still run fine, but it just makes people, when they're trying to read your code, it just makes this easier for them to actually interpret what is what, and it's like makes it easier to understand your program as a whole. And for constants, they're usually kind of like all capital letters, right? So for example, if you want to make a constant called max width, all of this has to be capital letter. So packages is something that when you're writing a huge program is very useful. So for example, if you want to, you can have packaging by functionality. So like you can have different codes that does different thing in different packages, for example. So the easiest way to think about packages is that they are folders essentially, right? You put codes that does similar things in the same folder. So the conventions for naming packages is that they are all lowercase, and ideally, when you're trying to import something, right, it goes from top to low level domain. So what that means is that you always want to make sure that you have more general ones at the top and then follow one to those individual classes. So let's say you're trying to import, let's say, cheesemaker to Java in another class, and the cheesemaker Java is in a whole separate package, right? So there you have to import from the top down, from top level domain to low level domain. So from import com.example from main.cheese. And these are all just individual packages or folders okay. So we're gonna move on if you don't have any questions. So declaring variables. So there are kind of like two ways to declare variables. So let's say you have, so when you want to declare variables, you must make sure that you have the variable type before the variable name. So in this example, X is the variable name, and then string is the type of the variable, all right? And you can either assign a value to the variable as you are trying to declare them, or you can assign the values afterwards. So in this case, we first declare the variable first, and then assign them afterwards. And in this case, we just kind of like declare and assign the values on the same line. So it depends on what you want to do. Sometimes you may want to go with the first option, and you want to go with the second options, but they are all equivalent way to do things essentially. So I'm actually going to talk about something else first. So when running a program, you often find yourself needing to actually write variables that are constant. So for example, if any manual programs, you use pi, for example, right, 3.15, and it's a constant, so you don't change pi, the value of pi. So what you do is that you have to use the final keyword so that anyone who uses the software can like overwrite the value of pi, right? So if you use the final keyword, it will basically declare the variable as final or constant, which means it is only read-only and it cannot be changed. So just a quick demo here. So I'm trying to assign b to an integer, and I just assign it, for example, to 3, right? And then like a float, which I assign values later. So just something that is very interesting about Java is that when you're trying to assign a float, you must put an f behind, and that is something, this is a convention of Java, and if you don't put f, it actually will not run, even when compile. So you have to put f whenever you have the float. Float is just a decimal, a type of decimals essentially, in simple words. And double is just another type of decimals, really. And with double, you don't really have to put an f behind. So again, I have a string type. So I have assigned all these variables. I've declared all these variables. And what I can do is I can just combine them up with the operators that I just mentioned last slide, and VW plus X. So it basically means 3 plus 3.5 plus 5.5. And because we are adding integers and floats and doubles, and you can expect the final answer to give something of a decimal point with I believe this is a float type. I think it's double actually, but yeah. And then you can also add strings together. So if you want to add hi and world, you can just literally just a plus b, because a refers to hi, b refers to world. And then if you want to add something in between, for example, a comma and a space, you can just type in that literally, and then it will print out hi world. Something that I want to demonstrate is that, so this z variable, it is final. So I declare it to be 5. So when I print this, it should just give 5. It shouldn't be surprising that I give 5. But now I want to change it to 10. right? And you can see that my software is giving me a warning already. It says that I cannot assign to a find variable. So what if I want to try to print out Z? Do you think you can run, or you can, or can this even be compiled in the first place actually? So if you just try this, you can see that it can't even compile because this is a checked error. And if you want to always try to like, so this shouldn't really be happening. So when Java is trying to compile this code, it realized that I'm trying to overwrite a constant value, and they don't like it. So they were just kind of like make sure they'll just give you an error and just stop the compiling process. So I can't even run this thing essentially. Does anyone have any questions before I move on? If I'm going too fast at any points, feel free to just slow me down or something like that. Or you have in the chat. And if you have any questions, feel free to just type in the chat, and Lisa and Jolina will help answer them. Okay. So move on. So there are, I also introduced them, as I mentioned them. So there are different types of variables in Java. So you have integer, you have float, you have double, you have char, which is character. It should just be one character. Booleans and string. There are a lot of other types essentially, but it's just some types that are, I guess, people use more often. They are like kind of like essentials. So something that you may notice is that most of the variables, they start with not capital letters, but string starts with a capital letter. Oh yeah, this is a quick kind of message. Booleans in Java, they are not capitalized, so they start with a small capital letter D. So if you're familiar with Python start with a capitalized D, but this one is not capitalized. So one question that I have is that why is string capitalized? Does anyone have any idea of why string is capitalized and why is it different from other type of variables? So this kind of brings me to the difference between primitive and reference types. Primitive types, for example, char, int, float, double, they start with lowercase letter, and they are initialized by default. So if you don't assign it to any values, there's just a default to 0 for all these values, for all these data types, and for Boolean, it's default to false. And primitive types, right? They store the value directly within itself. They store the values directly within the variable itself, and they are immutable. So you cannot change it. You cannot change the value of this unless you reassign it to another value. So there's a subtle difference between reassigning and changing the value. So what it means that you can, so if you declare an int z to be 5, you can't change the 5 anywhere. So if you want to change the value of z, you have to reassign it. You have to kind of like write line that just write z equal to 6, for example, if you're reassigning to another value. And for reference types, they start with an uppercase letter, and they can be null. For example, string or any classes they define, they are technically reference types. And why reference type is that they don't store the value directly within itself, right? It stores the location of the value in the memory space. So as you can see, so this is a value types, and it stores the pointers. So it stores the pointers to reference type. It stores some sort of like the memory locations that it can bring you to the value. Okay, is that clear? So what it says is that with reference types, it doesn't store the value itself. Rather, it stores the memory locations of the value. So whenever you want to access that value, you kind of have to like look up that memory locations and then find the value in that memory space. And reference types, they are usually mutable unless it is string. Kind of a tricky thing with Java. So I'm going to stop here for a couple seconds before I move on. Okay. Now continuing with the kind of like the talk with primitive and reference types. There are two ways we can compare things in Java, which is through the double equal signs or the method not equals. And it actually behave differently with primitive and reference types, these two methods. Sorry, let me just check. Okay. So I have all this code here. So I have two primitive types here. And if I use the double equal sign to compare two primitive types, it just compares the values. And if you expect, and as you expect, this should print out true because I and J, they are, oops, sorry about that. Think, yeah, I and J, they're equal because they have the equal value, so it should print out true. Now, I make an variable of string type, which is a reference type, and a new one as well, which have the same string, but they are of reference type. So what this does is that it creates a new memory address to store string hello, and then this line also create another memory address to store string hello. So if we use double equal sign, right, on reference types, it actually compares the memory address. So as you expect, these two have different memory address, so it actually prints out false. So what if you want to compare the value of two reference types? And what you have to do, you have to use dot equals, the method dot equals, and this will compare the value. And since X and Y have the same value, it will print out true. Now I have a variable Z that I just set it to X. And what this does is that the variable Z actually has the same memory address as whatever X is. Because I just assign X to Z. And if you just compare, and if you, since X and Z has the same memory address, this X double equal sign Z will print out true. And similarly, because they have the same value, because X refers to hello and Z I just assign it to X, they have the same value, it should also be equal to Z. Sorry, equal to true. Sorry about that. And to make this more interesting, another way we can, so something that I maybe forgot to mention is that because string is a reference type, you can actually declare string with this new keyword and then put string, the type string, and then record the value that you want. So this is the usual way that we actually initialize any object that you actually create for yourself. So if you create your own class, for example, and you want to create an instance of the class, you have to use the word new, and then the type of the class, and then whatever value that comes after this, if there's any value. And it's giving me a bit of redundancy there because you can actually just replace this with something like this, just much more cleaner. But they actually behave differently because what this does, so I have string A and B that I just assign to high, and A double equal to B actually prints out true. And this is different from, in this case, X equal to Y. Because in this case, these two have two different memory address. And in this case, however, I'm sort of making this string behave like a primitive types. So by omitting this kind of this new string dot stuff, I actually make string a primitive types essentially. And so A double equal to B, because they're both acting like a primitive types, they're actually comparative values, and they just give true. And A equals to B, again, this is the same thing as the previous one, it comparative value, so it should also print out true. So this is true. Does anyone have any questions before I move on?
I have a question.
Yeah, sure, go.
In the before, yes, why A double equal B return true? No, it will be false because compare a different memory.
So in this, so for example, in X and Y, right? I create a new string object. So I create a new string object for X and Y, even though they have the same value. So whenever I use a new keyword, it basically assigns a new memory address to each of the variables, each of the value. But in this case, I don't use the new keyword. So even though string is a reference types, now it actually behave like a primitive types in this case, essentially, because it's not assigned any new memory addresses.
Okay, thank you.
Yeah, sorry, this is a bit confusing, and it's just Java is, for me, is a very confusing language. There are a lot of stuff that we can do in Java, and just I never understand it, but this is how they are designed and stuff. All right, let's move on to something called typecasting. So let's say you have a floating integer, right? So you have a floating point, you have a decimal place, you have a decimal numbers, okay? And usually, if you're doing math or just anywhere in general, you can actually convert float like a decimal point to an integer. You can also do the same as well in Java. So it's called primitive conversion. So you can convert a double to a float to long, and these are all kind of like just different types of types that can sort of like represent numbers essentially. So you can convert all this, and the easiest way to think about this is that a double can store a larger, not larger values, but just kind of a larger decimal places after, right? So for ints, you can store no decimal places, but for long, float, and double, you can actually store more and more decimal points after the decimal points, essentially. The actual theory behind it is kind of like concerns about how decimal places, how decimal points, and how they are designed in Java, but I'm not going to go into that today. But so the easy way to think about it is that int cannot store any decimal points after the int just cannot store any decimal points. But with long, float, and double, they can store decimal points, and double can store the most decimal values essentially. So before I move on to demo, you can actually also, so I mentioned that you can actually convert double to float to long and stuff like that, but you can actually go the opposite way as well. We're going to convert an int to a double, for example. So if an int, let's say 5, you convert to a double, it just becomes 5.0. That also works as well in Java. So quick demo. Okay. So I have an int 9, and I want to convert it to a double. So I want to convert int to a double. Now in this case, because I'm trying to make int a larger value, so I'm trying to widen it essentially. So I want to, because double can store more than decimal place, so it's actually larger in the sense than integer. So when you're trying to convert something from the smaller ones to a larger values, you can actually just assign this, make this, you can actually just declare a new variable called double, and then put my int here. So my int here is an integer type, but I'm assigning it to a variable of a double type. And this can be done automatically. And then if you just print out, for example, my int and my double. So my int is 9, and you convert it to, for example, my double, so you give 9.0. Okay, so you can also convert it the other way around. So let's say I have a double 9.78D, but you don't have to, I don't think you have to put a D there, but sure. So you have a double 9.78. I want to convert it to an integer. Now, since integer is a smaller type than double, you kind of have to do it manually. So you have to put a bracket and say, hey, I want to make my double an integer. Okay, or else it will give an error. Actually, you kind of have to you have to cast it first, and now it will actually works. So 9.78D, if you print out my double, it actually outputs 9.78, as you can see here. And if you once you convert it to an integer, it outputs a 9. So it's actually round down, not round up. So this is just a quick demo with kind of just how primitive conversion really works. So if there's anything you can take away from this, is that when you're trying to convert a larger type to a smaller type, you kind of have to actually manually cast it by putting the type in brackets. Okay. Now, typecasting also works with superclass and child class. So if you're familiar with the idea of inheritance, so let's say you define a class, and then you define another class that actually inherits from the class that you first created. So we have a superclass and child class. You can also convert very quickly the child class to a superclass and a superclass to a child class. So downcasting is a type that casts a type to its subclass, right? Because so you're trying to cast a parent class to a child class. So in this way, you have to manually put a parenthesis. You have to manually cast it, like how you do it here. But if you're doing upcasting, so you're going to cast a child class type to its parent class, it can be done automatically because every subclass is an instance of the parent class. I think I have a quick demo, but I'm not sure I want to show it now. Actually, I'm going to show it. So just to quickly go through this. So I have a type account, right? I'm not going to go through all these implementations. So I have a class that I define called account, and I have another type called deposit only account, which is a child class of account because it extends or inherits from account, right? So I make account 1, which is a deposit only account, and account 2, which is account. Now, I create a new list called accounts, right? Account. I'm going to talk about how we initialize arrays later, but right now, just assuming that we have an arrays of the account type. So account 2 does not have any issue because account 2 is of type account, but account 1 is of type deposit only account. It's not exactly account yet. So what it does is that when Java run this, it automatically upcasts deposit only account to the account type, so that it actually works with the account, a list of an account object. And now I'm going to look through the arrays essentially. So if account is an instance of deposit only account, so I'm trying to see. So let's say so account 1 is an instance of deposit only account, right? So deposit double is a method that only deposit only account has. So if you just put account.deposit only account.deposit double, it actually will not run. So you have to cast it to deposit only account. So here I'm downcasting. I'm making an account object to its child class, so I can use its method, for example. Okay. So this is a quick example. I'm going to move on very quickly. So we can also have conditions and loops in Java. So first we have if-else statements, while loops, follows, or element switch statements, which may be new if you have not encountered Java before. If-else statements, so it's used when you want to execute a block of code if a certain condition is met, for example. So this is syntax, right? If this is true, if this condition is true, we'll execute this. Else, we'll execute this other block. Okay. So let me just find it. So there's a lot of things. Okay. So if else loops. If time is less than 20, so this is less than 10, so time is 22. If time is less than 10, this will not run. Else if, this is just another variations, like if you have more than one conditions to compare, so you use else if. So you have to kind of spell the two words out individually. So else if time is in 20, and this is not true either, so this code will not compile, will not run. Else, and this is true, so it should output good evening because it doesn't met the other two conditions. Okay, let's run quickly. You should see good evening somewhere in the, yeah, somewhere here. Okay, while loops. So while loops is when you trying to keep running as long as the certain condition is true. Okay, so while loops, so I have an example here. So I is less, so I initialize I equals 0. So while I is less than 5, I want to print out the value of I. And then after I print it out, I'm just going to increment the value of I. So I plus plus just means, I plus plus just means I equal to I plus 1. Okay. So as you can see, after every loop, the value of I increments by 1. So from 0 to 1 to 2 to 3 to 4 to 5. And as soon as you reach 5, you shouldn't see anything here. So it should just give up 0, 1, 2, 3, 4. Okay. For loops. For loop is very helpful, especially when you know exactly how many times you want a block of code to execute. The syntax for loop in Java is a bit long-winded. It's not my favorite. It's not my favorite syntax. But essentially, you have this for loop here. So you initialize the variable, right? Int I, and then you want to make sure that when I is less than 5, you run this loop, and then after every loop, you increment by 1. Right. So statement 1 is that the scheme executed once before the start of the loop. Statement 2 is that the condition to be met for this block of code to be executed. Statement 3 is that what is executed after each run of the loop. So int I equals 0, I less than 5, I plus plus. So as you see, it should just print out 0 because that's the first run. Second run, the I is 1, so it print out 1. Third run is 2, and then 3 and 4. And then as soon as I is 5, the loop just stops executing, and then it just exits the loop. As you can see, this version of for loop is pretty long, and you have to write a lot of things, and you have to be very careful because you always have to declare the type of whatever I is, right? So if you have if you're trying to int or booleans, so non-booleans, right? Or doubles or float, you have to make sure that you declare the type first, or else it will cause an error. It will not compile at all. So there's a simpler type of for loop. It's called for each loop, essentially. Now, this version of for loop only works with an array or a list, essentially. So I have a list called of 1, 2, 3. What I do is that for int, so this is you always have to declare the variables, right? The type of the variables that you want to use. So int, for every number in the list numbers, I print out number. Well, this is a much simpler syntax, and you'll see it works because it prints out 1 and 2 and 3. But just one of the caveats that it only works with a list of an or an array or something that is, I guess, that you can loop with. So whatever the collections or any mapping or any dictionaries, that works as well. But it has to be something that you can loop around. So this is helpful because you don't really have to keep track of the index for each object. Okay. Switch statement is a fun one, actually. It can be used when you want to select one of many code blocks to be executed, given certain conditions. So it's just this statement, switch statement, is only evaluated once. And the value of index expressions here is compared with the values in each case. And if it matches anything, it will execute the block of the case. And there's also one default here, which will run if it doesn't match any of the cases. For example, I have an expressions I call happy set, and I want to make a switch based on the expressions. So happy set is not happy, so this one will not run, and this will not run. And finally, it will, and then finally it found a case where it actually matches the expressions, and so it will print out an emoji that is happy set. Here, emoji just happy set. I don't know if you can see this, but as a fun one. But yeah. So basically, what switch statement does is that it actually just kind of compare the expressions here to each of the case, and once it found one that matches, it will just execute a block. And you have to make sure that it breaks, like you break the switch statements after each case. Okay. So arrays. So the declared array, as I said before, right? For example, here, right? We put a square bracket after the type, right? And arrays in Java are fixed size, so there's no append or remove method in arrays. So you can declare an array with or without an initializer. What that means is that you can directly, for example, say, hey, I want an array of integer, and hey, these are the values that I want in the array, right? This with initializer. But if you don't want an initializer, if you don't want an initializer, you can say, hey, I want an array of string type, and the array is called words. And you have to just create a new string tree. And this tree just means that it can only host 3 elements. So this is the type without initializer. Okay. And after you have created an array, now that's empty for now, you can just assign it individually. So word 0 is a hi, word 1 is a hello, and word 2 is hola, for example. And this is how you actually access changing the element, the index. Okay, this is how you access the index of an array, for example. And you can also access the length of the array just using .length method, for example. Okay, so this is an array of length 3, so it should see that it prints out 3. Okay, so an array can only hold the same type. There are ways to work around it, but I don't think I have time to go through that. But right now, so an array can only hold the same type. And if you don't work around that, you use the object as a type. So every object, right, in Java, they all kind of inherits from object. So they are object. So object is a special type in Java that is like kind of like the root of everything. So you just say you have a string. A string is an object, for example. Okay, an integer is an object, for example. So if you use an primitive type, for example, so if an int, a bool, and stuff like that, a boolean and stuff like that, now you have to use a wrapper because, like I said, int, bool, all those primitive types, they are not essentially an an object. So they don't start with capital letter, right? And every object, every reference types has some capital letter. So if you don't use those primitive types as an object, you have to use a wrapper. So what that means is that, so I think I have an example here. So I want, let's say, int here. I'm going to put it in an array of type object. So this array accepts all types of different data types essentially. Now, int it's not an object because it's a primitive types. So what it does is that Java actually automatically converts it to its wrapper class, and this is the wrapper class for integer. Okay, and it is actually and then store that instance to my array. So the process here of storing a primitive type is slightly different because it has to convert it to a wrapper object first before it can store it in an array of type object. So you can also you can access by index or change elements in an array, but you cannot append or remove from an array because it's fixed size. You can also access the length of the array. You can also loop through the array, like I mentioned, the for each loop. And you can also create an array within an array. I'm not going to go into that, but essentially you can actually create an array within an array, but you have to be careful of aliasing. So I have codes that I don't have time to show really, but if you want, you can I will post this code afterwards, and you can go and look through it afterwards. Okay. The wrapper class, like I mentioned, provides a way to use primitive types as an object. So for example, float has a wrapper class called float. So sometimes you must always do this. For example, when a list only accepts object type, passing in a primitive won't really work. So you pass an integer instead. Now, if you just pass in an integer, it actually works because Java actually automatically converts it to its wrapper class. So that's kind of helpful. But the idea is that it must always be a wrapper class object instead of being a primitive type. Okay. I don't have time to go through everything. So methods, like I say, I'm going to quickly go through this. Okay, so it must be defined within a class, like I said. And there are also some predefined methods like system.out.println, for example, and some objects. So I also have method themselves, such as integer is wrapper class. You can also integer passed in, which just converts a string to an integer. And every methods you must define a return type, the name of the method, and also the access modifiers. And elements can accept 0 or more arguments. Though it's a good practice to actually avoid long parameter lists. And okay, I'm not going to talk about that for now. So here's a method that I create. It's called print emoji. So this private static, they are the access modifiers. I'm going to talk about later. Void just means that it's the type of return type that returns nothing. So if you want to, if method returns nothing, just put void there. But if you want, let's say, a return type that returns a string, for example, you have to put a string. Okay. And this is the name of the methods, and then this is the parameter list. And the parameter list, so this is the parameter. You must declare the type of the parameters. So the expressions must be of type string. Okay, this is how you accept methods. Something that's very fun in Java is that you can actually create multiple methods that have the same name, and that's called method overloading. So for example, I have two methods here that has the same name, but something that method overloading works is how it works is that you must make sure that the parameters are different, right? So this has no parameters at all, but this has one parameter, and that's how it works. If you don't put this, it will actually cause an error and say, hey, there are two similar, the same methods here. So you must make sure that you have you must make sure that the parameters are different if you want to use method with different names. So with the same name, essentially. You can do this as many times as you want. as long as you keep the parameters different each time. And that's what we call method overloading in Java. Right, so you can create a method name, but with different parameters. All right, and yeah. So unfortunately, it is 2, and if you're not free, you're free to go. I do want to say that I don't have the chance to actually go through too many stuff today, unfortunately, because I have quite a lot of slides left. Actually, not a lot of slides, but so next I'll talk about access modifiers and OOP in more details, talking about static versus non-static keywords and shadowing and inheritance, how it works in like that. And also I provide some Java programming practice if you want to kind of practice more Java and stuff like that. Hopefully just go through these questions here. I don't really have a solution for all of them, but feel free to just kind of like share it, I guess, with me on Discord or something like that, and then I can check whether you're correct. But I believe that it should be fairly easy to check whether you're correct or not, because if you're not correct, then you should expect the written value to be different from what you expect. But yeah, feel free to just kind of like, I'll also post this slide and the recording as well, hopefully today or tomorrow, and you can look through this yourself. Unfortunately, I don't have time to go through it today. So before we wrap up, does anyone have any questions?